Hey everybody. So today we're going to talk about confidence intervals. Now it's in the lecture 14 notebook. So I'm actually going to notebook 14 here on week 10, and it says one sample t-test. So when you get into this, you're going to see one sample t-test. Okay, and I'm going to pause the video for a second because we're going to scroll down to where the confidence interval section starts. And I shouldn't have said scroll down, I should have said hit shift enter because we want all of the code blocks up above to be activated. So if you need a moment, go ahead and pause the video and go hit shift enter, especially on the initialization code block. So we're going to talk about confidence intervals. And this is the way that statisticians estimate. Okay. Um, do you need to know this formula for the t-intervals? No, you don't. But it just shows you that we're going to use, this is the sample average. So we're going to calculate the sample average. This is the sample standard deviation divided by the square root of the sample size. And then this T star can be figured out. And together, this T star times the standard deviation divided by the square root of the sample size is called the margin of error. Okay? And let's just execute this code block. And it shows you what we're doing. You see the negative T star is a vertical line right there about -2. And the positive T star is a vertical line there about +2. And it traps the middle 95% of the area under the bell curve. The middle 95%, okay? And so the workbook says that, depending on what your professors do, if your instructor skips this, but you're personally interested, that you can use some values. And again, they're just showing you for confidence, if the confidence level is 95% and the sample size is near to 300, then T star is 1.968. And you don't need to worry about how to calculate T star, but it does depend on both the level of confidence you seek and the degrees of freedom. Now, degrees of freedom is just the sample size, basically, in a one sample situation. And there are ways to calculate it, right? And the SciPy stats does have this, this TPPF function does have this way to find T star, and you tell it the confidence level and the degrees of freedom, and it spits out what T star is supposed to be. Okay, and you can delve into that if you'd like to. But now let's talk about the important part of the lesson. And instead of doing the hypothesis test, which we did, do students take 5 classes per semester on average? Instead, we're going to ask ourselves, how many classes do they take? Okay, and so what we're going to do is we're going to calculate a confidence interval for the number of hours that, the number of classes that students take per semester. And how are we going to do that? Now notice that most of this is filled in for us. I just want to point out some important things. First of all, these functions down here that are in this code block require array data. So the first thing we're doing is we're creating this array, and notice that data is an array because we're using a dot column. Okay, so it's just getting an array of the number of courses column in the classes table. Okay, and then we're calculating several things that we need. The first thing we need is the mean or the average, right? And so NP mean for the data, this will take the data array, push it in that function, and we'll know what it is. As a matter of fact, it's showing down here. STE, we're taking, that's for standard error. And that's going to use this SEM function. All right, and again, the array data is put into that function, and now we have the standard error. The standard deviation is calculated with this T standard deviation, so just the function np.std will produce the standard deviation. But the standard deviation that we use for the t-test is slightly different. So TSTD is the standard deviation that we need. And by the way, you'll notice down here we don't actually use the standard deviation, okay? So what are the 4 things? And notice that that we download this SciPy.stats as stats. So basically this stats that I am looking at is the stats right here. is calling the SciPy stats, SciPy.stats. Okay, and SciPy.stats has this function that we're trying to use called t-interval. And we need 4 things, right? We need the confidence level, we need the degrees of freedom, we need the average, and we need the standard error. Okay. So we've calculated the standard error and we've calculated the mean. So we've got 3 and 4. Okay. And this is fine. Just leave it. Don't worry about it. And then the degrees of freedom is n minus 1. Okay, so the sample size is going to be the length of this array. So if there were 100 people in our sample, then there's going to be 100 numbers in this array, and LEN of that data is going to produce the number 100, which is the number of people in our sample, and we're going to subtract 1. So degrees of freedom would be 99 if we had 100 people in our sample. Okay, so then degrees of freedom is going to be calculated right here. And then the only other thing is it's saying, hey, put the confidence level here, and it's doing the division by 100. Why? Because in the function, it actually wants the decimal 0.95. Okay, but they've made it real easy, so you can just put in the whole number percentage, right? So if it's a 90% confidence level, then we can use, 90, and the division is done down here in the function. And when we run this function, okay, it calculates the sample mean, 5.01, and the sample standard deviation. It tells us degrees of freedom. And then this is the key part. This is the confidence interval. This is what we were asked. And so what do? And remember that this is an estimate. Now, we tend to estimate with numbers. Statisticians tend to give an interval. They'll say it's between something and something, right? So remember, this is their estimate, and they're saying, look, the number of classes that students take per semester is between 4.94 and 5.1. I did a little rounding there, so 4.937 and 5.096, right? So the statisticians will say they're 95% confident that the average is in there. Now, I just said something that's not quite right. And I want to talk about this. What exactly does this mean? Okay, so the whole idea is to use the sample statistics to estimate what the population average is. Okay, but let's suppose that some researchers are studying perfectionism on the UNG Dahlonega campus, and let's suppose that the UNG undergraduate population is 7,000 students, and the research sample is 100 students. Okay, so they actually go to randomly selected 100 students and collect their data, and let's say that they create a 95% confidence interval for the average perfectionism score. Are we 95% confident that the population average is going to be in there? By the way, this is a question on homework 8. I'm not going over this just, I mean, it is important. I'm going over it because it's important, but I'm also going over it because it's a question on homework 8. And no, it's not, we're not saying that we're 95% confident that the average perfectionism score for the population, right, not the whole Dahlonega campus, is in there. So what we're saying is that, hey, out of this 7,000 students, if we repeatedly draw samples of size 100, we expect 95% of those samples, of those sample means to fall within the interval. Okay, so what averages are we capturing? We're saying, look, if we redo lots of samples of the exact same size, right? The sample size has to be the same as we were using up here. But if we repeatedly draw the samples of size n equals 100, then we expect 95% of those sample means to fall within the confidence interval we just created. Okay, we do use this confidence interval to estimate the population average perfectionism score. So even though we only talk to 100 people, right? I'm sorry, I guess it's up here where we have the 100 people we talk to, and there are 7,000 students in the population, we're still using this to estimate the population average perfectionism score. Now, the question's going to ask, you know, are we 95% confident that the population average is in the confidence interval? Okay, and the answer is no. And even though it's what we use it for, there is this slight nuance that what we actually know is that the confidence interval tells us that if we redraw samples over and over and over that are the exact same size, 95% of those sample means will fall in the confidence interval. Okay, that and make a note of this, right? That drawing repeatedly samples of the same size as in the original situation, right? So if we repeatedly draw samples of the same size, then we're going to get 95% of those sample means to fall in the confidence interval. Does it mean that we're 95% sure that the population average perfectionism score is going to fall in the interval? No. Okay, so again, there's a question on homework 8, and the answer is going to be no. No, that's not what we mean. And what do we mean? You can explain this in your own words and get the question right. But it turns out that we do use this process of we do use this process of creating the confidence interval to estimate the population average, right? This is how it works. This is why we're creating the 95% confidence interval. It's just that we're not 95% confident that the population average is actually in this interval. It's this that we're 95% confident of. Okay. Is it a good estimate? Yes. Yes. And approximately 95% will of the time, the population average will be in there. But again, there is this nuance, and I just wanted to make it clear before you face the homework what we're dealing with. So now we're returning to our example, and what we're doing here is just seeing, in red, we're seeing the confidence interval. Okay, so it's a 95% confidence interval. So let me draw on this a little bit. There is a vertical line at T star, right? And there is a vertical line at minus T star. Okay. And suppose that we shade the area to the left. Oh, wait, I'm sorry, I got this. This is negative T star over here, and this is positive T star, sorry. And if we shade to the right of positive T star, the total amount shaded will be 5%. So what we're capturing in here is the middle 95% of this bell. So we create a bell shape distribution based on T, which the T distribution is bell-shaped. And we find the middle 95% of that distribution based on the sample, and we assume that the population average is going to be in here between these numbers, between the 4.9 and the 5.1. Okay. And they're just showing the confidence interval in red. Okay. And how do we report this? So we're going to say, right, that the 95% confidence interval is between 4.94 and 5.1. Now, there is this other way you'll sometimes see these margin of errors. You'll see them reported with the margin of errors. So they're going to take the average plus or minus the margin of error. And this is what you see in political polling. I know that in just about a week, a little bit less, we're going to be voting in the 2022 midterm elections. And you see this all the time, that they estimate the percentage of people that are going to vote for a candidate. And if you read the fine print, they'll talk about this margin of error. And they usually will have, in political polling at least, usually have about a 3% margin of error, plus or minus 3%. So if they say the candidate is polling at 52% of the vote, what they actually mean is that they're estimating with a confidence interval that they're going to get 52% of the vote plus or minus 3%. So they're saying, hey, it could be anywhere between 49% and 55%. I don't know. But this margin of error format, you don't have to be particularly worried about it, because we generally do use the interval format. How do I find this? Well, this number is halfway between the endpoints. And then I can subtract the 5.1 minus the 5.02 to get the 0.08. So it's not a big deal to convert back and forth between them. Now, this would be an important part to read, because this explains how to do a hypothesis test with a confidence interval. And that is on homework 8. And basically, right, we set this up, and remember, mu sub 0 is the number that I use in my null hypothesis, okay? So if the number is not in my confidence interval, then I reject the null. If that number is inside the confidence interval, then we fail to reject the null hypothesis. Okay, so you can use these confidence intervals to conduct a hypothesis test. So second question, how many hours of sleep do students get on average? So notice what they've done. This is the exact same code block as above. It was just copy pasted down with what change? Well, they switched to sleep hours. So they're recreating this data array, and they're calculating the same things as before. They're calculating the mean, they're calculating the standard error, they're calculating the degrees of freedom, and they're giving it a confidence level of 95. And when you run that, again, they're showing us the confidence interval in red. Sorry, I jumped too far. So we estimate that the number of hours of sleep that students get is between 7.2 hours and 7.5 hours. Okay, that's our 95% confidence interval. And they're saying if you repeatedly draw from this population, then about 95% of the time you'll get sample means that fall within this interval. This is our estimate of the population average. Remember, the population average is mu sub 0, and we assume that that's in there. But as I just explained, we're not 95% sure that it's in there, right? We're 95% sure that when I draw repeated samples of the same size, those sample means will be in the interval. Okay, so once again, they've given a visual display of the 95% confidence interval. Notice that the blue bell-shaped curve is created based on our sample data, based on the sample mean and the sample standard deviation. And then we calculate the confidence interval, and basically that's the middle 95% of this bell shape that we created based on the data. And how do we report it? It's written in words what I just said. Our 95% confidence interval is between 7.21 and 7.51. Or you can do it with the plus or minus margin of error method. Okay, so now we were testing this hypothesis about sleep as to whether or not students get less than 8 hours of sleep, and then we tested whether or not they get less than 7.5 hours of sleep. Okay, and so interpreting the confidence interval does not actually lead to the same result. So you want to check this out. There's a reason why. If your alternative has a direction, right? So this is a directional. So the confidence interval, the 95% confidence interval will match if our alternative hypothesis was a not equal to, which is a two-tailed test. But it's not. Our alternative hypothesis is less than, sorry, let me get rid of that, is less than, which is a one-tailed test. Okay, and if you recall, we did actually cut the p-value in half, right? We divided by 2. Well, we have to do the same thing. And so instead of using a 95% confidence level, they are going to use the 90% confidence level. And they calculate 7.23 to 7.49. And so at the alpha equals 0.05 level of significance, we are going to reject the null hypothesis, right? Remember, if the 7.5 were in the interval, right? If it were actually in here, we would fail to reject the null. If it falls outside of the interval, right? If it's beyond the endpoint, one of the endpoints, then we if it's outside the interval, we reject the null, which is why they choose the reject the null hypothesis. So they're just showing you how to use this as a hypothesis test. And yes, there is one hypothesis test to do like this. And let me just jump up here. So I pointed out that this whole code block was copied from the first t-test we did. Be ready to copy paste this into homework 8, because you are going to be asked to do the confidence interval. And again, what do you need to do? You need to have this, and you're going to have to create a data array, taking the table where the data is and use a dot column to grab the column in the table that you want to turn into an array. All right, so we're down past this 90% confidence interval that we have just done. It's showing it here, and the little green dot, if you can see it, there's a green dot right here that I circled in red, and it is just outside the interval, just barely, right? Because the confidence interval goes to 7.49, and 7.5 is the value that we were looking at. It does turn out to be reject the null, but it's really close, and you can see it in that drawing. And now we're going to estimate the average birth weight of babies born to mothers that do not smoke. If you remember, we checked this, I believe it was 115 ounces or 118 ounces, and we checked to see if it was more or less. And now the question is, hey, don't figure out if it's more or less, just figure out just give me a confidence interval for the birth weight of the babies born to mothers that do not smoke. Okay, and so notice what happens. The same thing that you're going to do on your homework, they just copy paste this whole cell right here. And what do we have? We make sure that we create an array called data, and it's table dot column and then the name of the column that you want to make an estimate of. And make sure that it's numeric. It has to be a numeric column. And then we calculate the mean and the standard error and the degrees of freedom and the confidence level. Okay. And again, the only thing in here that you really need to look at is just to make sure that your confidence level is correct. Everything else you can, after you fix this, right? After you get the right data entered into the data array, everything else is calculated for you, but the level of confidence may change. So you may have to fix that. And then you can just run the cell. And since they're doing a 95% confidence level, again, boom, we can see that we would say the average birth weight of these babies to the non-smoking moms was between about 117.6 ounces and 130.5 ounces. And again, there is a bell curve, and middle 95% is shown in red there. That is the confidence interval. And then the lecture notebook goes into Bootstrap, and we are not going to do this. So this is the part of this is why we're not doing section 1 of homework 8, because section 1 was creating functions to do this, and a lot of it could be copied out of this, but you had to understand how to do for loops, and it included some coding that we're not including in the course right now. So that's why the instructions in D2L were to skip section 1 of the homework. So we're done covering the confidence intervals, and I was trying to give you some hints about how to complete homework 8, and make sure that you don't worry about section 1. Just start with section 2 on homework 8, the confidence intervals homework. Have a great day, everybody.